Hi, good afternoon, everybody. I want to introduce this lab. This lab, we are going to complete it in 2 weeks. Then next week is going to be a consultation in case you have any questions. You will not submit this lab until May 15th, okay? Now, we are going to study the diffraction pattern and the diffraction equations using a diffraction grating, and we're going to study different parameters. Let me see here. You can see here my okay, let me close this, and here what you can see is my home page for this lab. This is the instructions, this is the submission, and this is the rubric. Now for the instructions, okay, I have here, all right, just also I want to share with you something in this here so that you have access to it. I shared with you a template that I have created the columns for you on Excel, and for the rest of just for one task, and then for the rest you are going to copy paste with special, okay, that I will show you. Yeah, then this is really the template here where I can say not this one, this one. Okay, then here I have embedded all my equations that I'm gonna use so that you will be able to, maybe just enter your numbers, and then you are going to be okay. Now let's go back to the okay, it's gonna be O physics, okay, and therefore if the link did not take you, you're gonna try to find O physics, and then under light you will have the diffraction grating laser lab. Now for the first one, of course, this is gonna be an official lab report. You are going to submit both your Word document together with your I will say Excel sheet. You're gonna divide your lab into 3 sections: task 1, task 2, task 3, with the same titles that I have here: study the effect of lens to grating distance. Okay, and the first factor that we are going to study, it is the lens to grating distance, which is we call it R, this the screen to grating distance, this distance here. Okay, therefore we are going to keep the length fixed. You can leave it as 532. You're going to keep also the grating lines per millimeter as 300 constant, whatever if you like, you can change them. And then you are going to keep changing that distance here from 5 to 10. Then I will say we are going to start from 5, and then look here, that is really the the dots here, they are really represented also here on the screen on this ruler. Okay, then you're gonna say for you're going to have the pattern here. You're gonna input that distance, which is 1, 2, 3, it's just one, not one, it is 0.5 it's about 0.8, okay, which is the spacing, which is Y. This is gonna show you the spacing between the diffraction patterns on the screen, and therefore this is my Y. Now this we are going to measure only for n equals 1, which is this one, and either way is gonna the same. Okay, we are going to prepare the table to record the values, and we need also in our data to record what is really the wavelength that we have, and also what is the grating lines per millimeter that we did use. I added these to the table, and therefore, okay, let me show you, share with you my own thing here. This is, okay, then I added here M is 1 for all. Did I say N? M is for all. D, it's the same. How we calculate C, how we calculate D, sorry, it is, it said like 3 lines in 1 millimeter, then it is 0.001 divided by 300. And I'm gonna measure Y for M equals 1 as I am changing the screen distance. All right. This one here, it is when we well say we want to find the angle. Therefore, I did this in steps. The first one here is I calculated tan theta, which is Y. Okay, I'm using in my handout N and in my Excel M. Okay, my N is my M. Okay, then Y M divided by R. This is just I divided this column D by C, by A, sorry. Okay, then here I divided this by this. Now I found what is tan inverse here. Okay, and that one is the function. You can see it here. It is called we call it like arctan. Okay, and this is to calculate what is really the theta for that. Remember, theta here, it's in radians. I did calculate here sine theta, and then I multiplied D times sine theta, and then I divided by M, which is here 1, is not going to make a difference. And I did use the equation, which is D sine theta equals M lambda to calculate my lambda. And then I calculated my lambdas here, and this is my average lambda. I hope this is really clear. I did these in like steps. Now, for after I'm done with this, you're going to calculate the average of the wavelength of this laser. You are going to plot a graph to show the relationship between YN and R. And you are going to fit it to a straight line. Like you can see here, it is like here I did not actually finish my labels, but this is really the, you know, the graph. I should have a title. And you are going to use the trend line to calculate the wavelength of this light and list the calculation under calculation section. And you are going to calculate the percent difference using your theoretical value. All right, then this is really the first part. Okay, now I want to show you how because in your case, what you have, like the template that I have provided for you, it is this one. And if I want to make copies of this, you're going to come here, select everything. You're going to say copy, and then you're going to move here. When you are going to paste, you're going to say paste special. And then you are going to, not values, we are going to have the formulas and number formatting. Like everything should be the same. Okay, let's, I think maybe because I did use the, okay, I should copy, I should paste using the formulas. Okay, okay, and but you are going to, I don't know why it did not work here with, like it should work with, okay, let me redo, okay, like I don't know why it did not give me the numbers that I'm looking for. Number formatting, because I want to have these digits. Okay. Oh yeah, now it's working. Yeah, because we don't have enough. Okay, then here this is my and then here now when you are going, but of course you're gonna make changes based on what really required from part 2. Okay, let me show you part 2 and then we're gonna come back to the Excel sheet. Study the effect of the grating lines per millimeter, which is really the spacing you know, between the lines. And here what I will do is I'm gonna have the screen distance and the wavelength is like a constant value. You can have it 5, and you are going to change here, okay, that number, okay, and I will say we are going to move from 200 to 500 in increments of 50. And again, we are going to measure the distance between the dots on the screen for n or m equals 1 only, and we are going to record the values, the same thing, okay, the same thing exactly. Then here when I go to my Excel sheet, okay, sorry, when I go to my Excel sheet, okay, this is my task number 2. I did use 8, and then lines, these are really the lines, and then I was able also to do the same kind of measurements. For the second chart, you're going to graph relationship between yn and d, and in order to fit it correctly, you should have it in fit it to power, okay? And of course here again, I did not worry about my labels and things, okay? Number 3, of course, is gonna be when we are going to change our like we're gonna keep this constant, this is constant, and we're gonna change the wavelength, okay? And we are going, like, as you can see, as we are changing the wavelength or the frequency, the color is changing. And you are going to change the wavelength from 400 to 700 in increments of 50 nanometers, and you are going to do the same thing. And then you're going to also here we will not calculate the wavelength. Since I'm changing the wavelength, I will calculate what is really my average d, because remember we fixed d here for this, which is the distance between the I would say the slits or the lines, and therefore what I'm gonna get is I'm gonna get values for d that they should be like similar, and therefore I'm gonna find what's the average. And I will also have the graph here. This is the graph, and we are going to fit it to a straight line, and we are going to use the trend line to calculate d. Okay, d, it is the spacing between the slits of this diffraction grating, and you are going also to calculate the percent difference. Okay, I hope it's like straightforward and no problems in this lab. Thank you very much. This is our last lab for this week, for this semester. Thank you very much for this great semester.